Okay, I thought I would illustrate the free body diagram a little differently. This is a simulation on physics, education, technology. This is a Java program, so it doesn't run on a Chromebook. But if you take a look at this at home, forces in motion, if you have a regular computer, you can get this to run. You can see up here in the upper left-hand corner, there's a little robot pushing a file cabinet. Fn is the yellow arrow representing the normal force of the floor pushing back. The partially obscured blue arrow is the weight of the file cabinet, something like 500 newtons. It's a 50 kilogram file cabinet, so that would be a little over 100 pounds. The applied force is 247.5. I don't know if you can see that right there. I don't want to change the number, that's why I'm being a little careful. And there's a friction force, that's a red arrow pushing to the left. The applied force, which is the one I've dialed in, pushes to the right. And there'll be a slight net force that will cause the file cabinet to inch to the right. So let's set this off and running and see what we see. So let's see here. Okay. So the first thing you see is the sum of the forces here, which is actually not very much because the acceleration opposes that. I hope you can see that mark I'm making there. And directly under that is the acceleration. And you can see over to the left in kind of that bright green, it's calculating the acceleration for you, but that's just going to be the slope of the velocity. So if you go to the velocity curve, which is the red curve, and you go out to 6 meters per second, that happens right at 2 seconds. So the change in position is 6, and the change in time is 2. 6 over 2 is 3, which you can see right there. And the area under this is a little difficult because we start in the negative, but we start at -10 and we wind up at I just stopped it close to +10, about 8.5, just before it collided with the wall. But over here, I'd just like you to see that here's the free body diagram here. Again, the yellow is the normal force. The orange-ish, yellow-orange, is the applied force going to the right. The red is the force of friction, and the blue is the weight of the file cabinet. Okay, and this green arrow up here is actually a force that doesn't really belong on the free body diagram, so they put it off to the side. That's actually the net force, and you notice that's a lot smaller. Okay, so that's actually this number here. Let's see, can we zoom in on that? Actually see how big it is. Okay, so it's like 135 newtons, something like that. So that means that we're actually getting this going at quite a clip here. So again, all you have to do in order to draw the free body diagram is represent all the forces acting on the object, represent each one with an arrow radiating out from the center of mass of the object, and pointing in the direction of the force, right? And each arrow is proportional to the size of the force. Okay? So I hope that made more sense than going through Discovery Education. A little bit more applied anyway. Okay.